Okay, we've got a January 2008 Edexcel exam. Two fairly standard integrals, okay, we're going to look at. The first one is a log, okay, it's always going to be integration by parts. There's lots of log integrals that are going to be integration by parts, and we'll talk a little bit about the kind of variations you might see in other exams, where again you're going to use the same process. So the second one, okay, you should look at that and think about trig identities, and you should know that you can reduce that using your double angle formulas, rearrangement of your double angle formulas, okay. So let's go and have a look at the first one first, so 4i, okay. Okay, so integration by parts here, okay, and this, we just make the point, you know, there's lots of integrals like this. You might want to consider trying to integrate, for example, x to the n ln cx or something like that, or where that's just a constant delta x, and you'll see, okay, it's going to work out via integration by parts. Okay, so this form, or more generally sort of this sort of form, you know, be looking out for integration by parts. So let's go through the steps of integration by parts. Now, really, integration by parts is it's just the product rule rearranged and integrated. Okay, so that's the answer of the product. So that, yeah, that was, we'd put derivative in there. That would be the product rule. Okay, and that would equal these two. Okay, so if you think about differentiating this whole lot and rearrange it, you can probably see you get the product rule. You just put this over the other side. Okay, if it was differentiated, then we'd undo the integration, wouldn't we? Same with this one, and you'd see, and obviously we put the differentiation in here, and you can see that the product rule is pretty much there. Okay, so what are we going to pick? We're going to pick, and the other thing, when you memorise this, you probably should memorise it. Don't sweat about the u and the v here, whether it's the u and the v here. If the u is not differentiated here, it's going to be there. Okay, so if you were to put v there, then you'd have dv by dx over here, and u and du by dx, or however you order it. Just make sure that if you've got u there, you've got du by dx here. If you've got dv by dx there, then you've got v there, or vice versa. That's absolutely fine. Okay, and again, you can. That's just because it comes from the product rule. It doesn't matter about you using your v's and which way you do them. So the first part, we're going to have u is equal to log x all over 2. Okay, so you're always going to set the log term to be the one that you're going to differentiate, because it's very easy to differentiate a log. And the other one here is going to take to be 1. Okay, it seems a little strange, but obviously if you look up here, you know, there's no reason why we can't do this. Yeah, so that's going to give us, if dv by dx is equal to 1, then v is obviously equal to x, and you can see from, you know, the top and bottom, okay, differentiate the bottom to get to the top. Okay, then that's going to work, isn't it? It's going to work there. It's going to give us 1 over x. Okay, so let's have a little look further down then. We put all those parts in, then we've got okay, u and v coming in here, yeah, and du by dx and v coming in here. Okay, that's where they've come from, and all we're then going to do is integrate these up, and that's very convenient. It drops out to be 1. Integrate 1, you get x. That's already done for us. Okay, so you need to put the constant at the end because it's an indefinite integral. Okay, so the next one, you know, anything, if it was cos squared or sine squared, you'd do a very similar thing. Okay, now I tend to remember, more than anything else, I tend to remember this identity for doing this sort of integral. Yeah, I think you're better off maybe memorising both of the ways around. If this was cos squared here, we'd be looking at 1 plus cos 2 theta anyway, but we'll take a step backwards. Okay, so I memorise this one because I know I can get it cos squared and I can get it sine squared, whichever way. Okay, so I'm going to put cos squared, get rid of cos squared because we want sine squared. Obviously I'm just going to use the very, you know, the age-old sine squared plus cos squared equals 1. Okay, I've dropped the argument there, right? Doesn't really matter. Okay, so I'm going to put that in, and I'm going to get, obviously, you know, cos squared is 1 minus sine squared, blah blah blah, put that one out, then I get this here. Okay, now this is just rearranging, okay, now get it in terms of sine squared. So we wind up getting sine squared to that, and we put that back into the integral. Okay, we get a half there, and we get 1 minus cos 2x, we integrate that up, we get x there. Okay, then to get rid of, obviously when we go, yeah, the half comes in here because when we differentiate sine 2x using the chain rule, you're going to get a factor of 2, which you need to get rid of. Okay, put the limits in, and the rest is really just algebra. Okay, so it's pi by 2 at the top. Okay, but 2 pi by 2 is pi, which fortunately we know to be 0, don't we? So that one's going to go to 0. Yeah, if we look here, we're going to put pi by 4 minus a half, sine of pi by 2, sine of pi by 2 we know to be 1. Okay, so that helps us a little bit more. We'll get rid of the 0, and we have a minus pi by 4, and the minus becomes a plus a half. Okay, and that gives us our final answer there. Okay, hope that was helpful.